Hi everyone, in this video we will be discussing the units of viscosity. As you are aware, viscosity is a measure of fluid resistance to flow. And you maybe remember the old school example, honey is more viscous than water, and just because of that water will flow easily, and for honey it will take some more time. And we are not discussing viscosity deeply in this video. This video is mainly focused on the unit of viscosity and what are the different types of viscosity. Maybe you are confused about certain terms in viscosity such as dynamic viscosity, absolute viscosity, and kinematic viscosity, and so on. If you are confused about these kind of terms and the unit of viscosities, what are the unit of dynamic viscosity and how to find the unit of kinematic viscosity, and what is the SI unit and what are the other industrial standard units, and how to convert in between this unit. If you want to learn how to convert between the units of viscosity and how to derive the unit of viscosity and so on, you are in the right place. The equation of viscosity can be easily derived from Newton's law of viscosity. If you are not aware about Newton's law of viscosity, you are advised to check on that equation. As per Newton's law of viscosity, it says that the shear, that is the toe, the shear is proportional to the rate of change of shear strain in a viscous flow, that is tau is proportional to du by dv. This equation is what Newton's law of viscosity. Then the unit can be derived as follows. Since tau is proportional to du by dv, we can write the shear stress tau is equal to, if you want to change the proportionality limit, you have to introduce a constant. Here the constant is eta into du by dy. This proportionality constant eta is known as dynamic viscosity. So this is what dynamic viscosity, the proportionality constant which changes the Newtonian equation. Then remember the dynamic viscosity, also known as absolute viscosity. The things are same. So dynamic viscosity and absolute viscosity are same term. Don't confuse in between dynamic viscosity and absolute viscosity. Often these terms are expressed as simple as viscosity. When it is not particularly mentioned and it is expressed as viscosity, it means dynamic viscosity or absolute viscosity. Now we can derive the SI unit of viscosity. SI unit of viscosity can be derived from the Newton's equation, and from this equation number 1 I can write the viscosity eta, or the dynamic viscosity eta, is equal to the shear stress tau by the shear strain du by dy. Here we can, the unit of shear stress in SI is pascals and divided by the unit of du by dy. Here u is the velocity of flow, the unit of velocity is meter per second, divided by dy is the distance, that is simply meter, and we will be getting pascals by 1 by second, that is pascal second. That means the unit of viscosity in SI is pascals second. Pascal second is the unit of viscosity in SI, remember. Then we can derive other unit as well, and I can show you one more unit. Since pascal second is a unit in SI, I can also write that as Newton per meter square second, since Newton per meter square is 1 Pascal and Newton is equal to kilogram meter per second square. Newton is the force required to accelerate 1 kilogram of mass upon 1 meter, that is Newton is kilogram meter per second square. And applying that back in this equation, we are getting kilogram meter per second square by meter square into seconds, that is kilogram meter by meter square second square into second. Here we can cut 1 meter square here and a meter here, 1 second here and 1 second. That is kilogram by meter second is another unit of viscosity, that is Pascal second is equal to kilogram per meter second. These are the major unit that we often use to express dynamic viscosity or kinematic viscosity. Pascal second is in SI unit and this kilogram is often used in MKS system. Both are same. Pascal second is equal to kilogram per meter second. As we discuss, Pascal second and kilogram per meter seconds are the standard unit of viscosity, but in industrial practice these units are too large and we often use another viscosity unit known as Poise. So Poise is equal to 10 second per centimeter square and 1 Poise is equal to 1 tan second per centimeter square. This term tan is a unit of force in SI unit. It's a unit of force, and remember, if you are not familiar about tan, it's a unit of force, and 1 tan is equal to 10 raised to minus 5 newtons. And when you need to convert this tan second per centimeter square into Pascal second, we can write this as, so since tan is 10 raised to minus 5 Newton, this is 10 raised to minus 5 Newton second by meter square. To convert centimeter square into meter square, we will get 10 raised to minus 2 all square. That is 10 raised to minus 1 Newton second meter square. That is, we are getting 1 Pascal second is equal to 10 Poise. So 1 Pascal second is equivalent to 10 Poise. This is a conversion of Pascal seconds into Poise. But this term Poise is also little bigger. In small scale expressions, we are using centipoise. So 1 centipoise is equal to 0.01 poise. Same as centimeter is centi, 0.01. That means 1 Pascal second is equal to 1000 centipoise. So this is a conversion of Pascal second into centipoise. Whenever you want to convert the SI unit Pascal second or the kilogram meter per second into centipoise, you have to multiply it with 10 raised to 3, or in reverse, you want to convert centipoise into Pascal second, you have to multiply it with 10 raised to minus 3. So as simple as that, multiple with 10 raised to 3 when you want to convert centipoise into Pascal second, and 10 raised to minus 3 in the reverse process. And I can show you some other relationship. since 1 Pascal second is equal to 1000 centipoise. You can also write 1000 millipascal second. Don't confuse this as megapascal. This is millipascal second is equal to 1000 centipoise, or millipascal second is equal to centipoise. It's another equation or other relation, that is millipascal second is equivalent to centipoise. When you express the things in millipascal second, that is equivalent to centipoise. So these are the units for dynamic viscosity or absolute viscosity. Just recheck the unit. Pascal second is equal to kilogram per meter second is equal to 10 raised to 3 centipoise. So centipoise, kilogram per meter second, and Pascal second. These are the three units for absolute viscosity or dynamic viscosity. We discussed the dynamic viscosity. The other guy in this room is kinematic viscosity. Kinematic viscosity is equal to, is the ratio of dynamic viscosity to gas density. It's density. Dynamic viscosity divided by density. You will be getting kinematic viscosity. And why we are using kinematic viscosity in certain terms other than dynamic viscosity means kinematic viscosity will give you an idea about how that fluid will interact with the gravity, or how that liquid interact with the gravity. The flow rate of that liquid is mainly depends upon kinematic viscosity. You can expect a liquid with the same dynamic viscosity and different kinematic viscosity, or kinematic viscosity will give you a detail about the flow of that liquid under the influence of gravity. That's why we are calculating this fraction, dynamic viscosity divided by density. Mathematically we can write it as eta by density rho. Eta by rho. So the unit of kinematic viscosity can be derived from its equation. Since we have kinematic viscosity, we call that as V is equal to eta by rho. The unit of eta, that is dynamic viscosity in SI, is Pascal second, divided by the rho, the density unit is kilogram per meter cube. So that is Pascal second divided by kilogram per meter cube. So we have kilogram in denominator, in Pascal in numerator. We can solve this. So for that we can write Pascal second is equal to Newton per meter square. That is what the Pascal into second. But Newton is equal to 1 kilogram per meter per second square into second. So this is the conversion of 1 Newton, that when you have to accelerate 1 kilogram of mass upon 1 meter per second square, you need 1 Newton force. That is 1 Newton equal to kilogram meter per second square into second here, divided by meter square. So this is what the Pascal second. And now I can write the unit of kinematic viscosity as kilogram meter per second square into second divided by meter square here, all divided by kilogram per meter cube. And sorry, I wrote a meter square here. It is meter cube, the unit of density, and this is equal to kilogram meter by meter square second square into second here into, we will go for the inverse of this, that is meter cube by kilogram. This will be the final equation, and we can cut off meter square here, which with meter, and kilogram with kilogram, second square with second, and at end I will be getting meter square per second. So this is the unit of kinematic viscosity in SI. The unit of kinematic viscosity is, the unit of kinematic viscosity in SI is meter square per second. Even though it's look weird, it's a unit of kinematic viscosity, meter square per second. As same as the previous example, we are not oftenly use meter square per second for industrial purpose since the unit is very large. So instead of that, we often using centimeter square per second, and we have a separate name for this centimeter square per second known as stokes. So this is what stokes, the unit of kinematic viscosity that we are using, centimeter square per second is equal to stokes. That means the SI unit 1 meter square per second is equal to, when we convert this meter square into centimeter square, you will be getting 10,000, that is 10 raised to 4 centimeter square per second. That is the standard unit of kinematic viscosity. Meter square per second is equal to 10 raised to 4 strokes. So this is the conversion. When we want to convert meter squares by second into strokes, you have to multiply that with 10 raised to 4. This is also a bit large unit, and we are using centistrokes in certain application to measure very small amount of kinematic viscosity. Centistrokes. The centistrokes is equal to 0.01, that you guessed, 0.01 stroke. That is what centi, 0.01. And you know this is 0.01 strokes. That's equal to 0.01 centimeter square per second. And I can show you another relationship here. That is, I can write this as 0.01 millimeter square per second. So when we need to convert a centimeter square into millimeter square, you know, to multiply it with 10, that is 10 square, and this term will be cancelled, and you are getting, this is what the centistroke, 1 centistroke is equal to millimeter square per second, is another relationship. That is 1 centistrokes is equal to 1 millimeter square per second. So these are the important things you should remember. The SI unit of kinematic viscosity is meter square by second. When you need to convert that into strokes, the industry unit stroke, you have to multiply it with 10 raised to 4. In reverse, you have to multiply that with 10 raised to minus 4. And when you need to convert meter square per seconds into centistrokes, you have to multiply it with 10 raised to 6. That is, in reverse, you have to use 10 raised to minus 6. So these are the relation. The SI unit is meter square per second, and the other unit is stocks. You can convert that with 10 raised to 4, and is another smaller unit, centi-stroke. You can convert that as 10 raised to 6 multiplication factor. So these are the conclusion. The SI unit is meter square by second for kinematic viscosity, and we are using centi-stroke and stocks. Okay, see you in another video. Maybe you can comment your doubt.